All right. Hello and welcome. Can someone confirm that you can hear me and you can see my screen? Thank you, sir. Simran, thank you so much. Okay, try to. Right. Then my SPSS. Okay. Are there any questions? Anything?
I had a quick question.
Oh, sure.
So I was planning on kind of studying for this class in the library. Do you know if the library computers have SPS on them? Sorry, SPSS?
I'm not sure for the library, but the fishbowl, the Learning Commons, they have SPSS.
Okay, perfect. Thank you.
You're welcome. Another place is go to Mackenzie Chow J building. And then the room number 201 and 202. If there is no scheduled class, you can use SPSS. Okay. They don't. Abdul said they don't. You double check, okay? Maybe things changed. Okay. Okay. Other questions? A couple of logistics. I posted assignment on Sakai. Assignment is 10%. You can work with a partner or you can complete assignment by yourself. When you work with a partner, each and every person will submit assignment individually, okay? So the assignment is from the textbook. At the end of some units, you have questions, okay? Anyone want to work as partners? Yeah, you can maybe looking for partners work with for the assignment. And it is due March 17th. Okay. You need to use SPSS to carry out those assignments, to answer questions, and also attach related output from SPSS. Okay, so that is assignment 10% due March 17th. And the other thing is a group project. Almost all students have a group project. If you still do not have a group, please email me, okay? I will try to collect information to see who are not in the group yet. I'll try to put you guys into a group, okay? So that is the group. And for our midterm test, it is 1 week before the reading week. So today is February 3rd, February 10th. Our first test will be February 17th. February 17th. It is a 2-hour test, and you are required to use SPSS to complete some questions. So not all questions require SPSS, okay? So that is the test on February 17th in class. So we all go to the computer lab, Mackenzie Chow 201. It is 2-hour test from 1 to 3. The format of the test could have multiple choice questions, short answer questions, and fill in the blank questions. So mixed of those questions, all the questions will be available on Sakai. Some questions need to use SPSS or Excel to answer them. Okay, so that is the test 1. And for next week, our class is assigned to phase 2, return back to campus. So we have to return back to campus next week, but the delivery method will be the same. I will still hold the Teams meeting like today, like this one, okay? It is your choice for safety concern. If you have other concerns, you want to join the class remotely, I am okay with it, okay? But make sure you follow along the steps, the examples in class, and what happened next week when we return back to the class. Please follow the protocols posted on the campus. For example, mask must be weared, and this is a small class. I hope we'll have social distancing. Okay, have an empty computer between you and your neighbors. Okay. And so that is for next week, okay? The benefit of going back to campus for this class, one of the benefits I think is you can use SPSS on the computer, on local computer, not on the remote desk, okay? So it is your choice. So, but participation is required, whether remotely or in face-to-face. Remember, each week we have 1% participation. Okay, that's some housekeeping stuff. Any questions? Any questions, anything? Okay, so today, yes, Eric?
It looks like there's some questions in the chat. You just have it covered by the calendar.
Sorry. Thank you so much. Thank you so much, Eric. Yeah, there are some questions. Will the test be open book or closed book? Will get any practice problem? The test will be open book, open resources, open internet, but it is individual work, and you have to write the test on campus. Do we get practice problems? I'm sorry, we don't have a practice problem. Consider each example in class is a practice problem. Okay, make sure you fully understand each and every example in class, as well as remember each week we do a little hands-on. Also make sure you know how to do those questions, okay? The other question, so we still have written part and the computer component. That's right. Midterm, we will have written part. So the format is multiple choice questions, filling in the blank, short answer questions. Short answer is the written part. Do we have a rough number of questions for the written component? I would say maybe 20% of the written questions, around 20-25% of the written questions. Okay. Will the lecture be recorded? Yes, the lecture will be recorded even if we go back to campus. Next week, the lecture will be recorded. Okay. So please remind me if I do not quick record button. Okay. So what sections will be covered in the exam? The exam will be covered here. So our midterm exam, February 17th, today is week 4. Week 4, okay? So the midterm will cover anywhere from week 1 to week 5. Week 1 to week 5. So the beginning part of unit 8. Okay, so those are the coverage. Week 1 to week 5. Today is week 4. Okay. All right. Any other questions? All right, so we are going to briefly review what we did last class. Last class, we focused on hypothesis test. So I'm going to briefly summary what we did last class, and this summary is important. I did this summary. I will do this summary on purpose for our midterm on February 17th. Okay, so please pay attention to this summary. So just try to make a space. After I review last week, and today the lecture will be on Unit 7, Lesson 26, two-way analysis of variance. Our last class, we did Lesson 25. Okay, so today we'll do Lesson 26, and then we'll start Unit 8. We'll start Unit 8, Lesson 31, Lesson 32. Okay, so that is the outline for today. Okay. Try to manage multiple windows so that I can see your questions. Okay, review. Hypothesis test. For hypothesis test, any test, you have null hypothesis H0. You also have alternative hypothesis H1. Regardless the research question, H0 you always use equal sign. For example, the class average, mu, and the hypothesis is always targeting population. So population mu equal to 73. Okay, and if you are saying hypothesis H0 X bar equal to 73, that is wrong. Because X bar represents sample mean, hypothesis test always targeting population. Okay, so that is null hypothesis. Class average is 73. Alternative hypothesis always has not equal or greater than or smaller than. When you have not equal, you are saying the population mean is not equal to 73. If it is not equal to 73, we call this is a two-tailed test. Two-tailed test. Okay. And if H1 is mu greater than 73, we say this is right-tailed test. This is right-tailed test. And if mu is smaller than 73, and this is a left-tailed test. So 3 situations, okay? Some textbook also use H0, also can be used smaller equal or greater equal. But H0 will never have a smaller sign. Smaller sign belong to H1. H1 can have smaller sign. H1 can have a greater sign. H1 can have a not equal sign. Okay, so that is a null hypothesis and alternative hypothesis. And when you do the hypothesis, you are not 100, usually you are 95% confident. Okay, you cannot be 100% confident. That comes with the confidence interval. Okay, commonly used 95%, 90%, or 99%. Okay, and when you have those percentage, there are some critical values associated with those percentage. And you need to know how to find those critical values, because in class, I did some, when we did examples, some examples involved in critical values. So now I'm going to review how do we get those critical value. Okay, so there are two situations. One, if it is normally distributed, or if it is a student distributed, T distribution. If it is normal distribution, oops, I will take example of 90%. So if you are 90% confident to test a hypothesis, so the question is, what are those critical values? We call Z half alpha. If it is two-tailed, you have two critical values. The question is, how do I find critical value Z half alpha, given it is 90%? Okay, you do this. You modify this diagram to, if the central area is 90%, so this is Z half alpha. And the area to the left, of this Z half alpha, what is the area? 95%. Okay, so why I need the area to the left? Because Excel is based on area to the left to calculate the critical value. And critical value, maybe if during the test, I will use maybe multiple choice questions or fill in the blank. I just need one number. Okay, for example, I give you 90% confidence level. What is the critical value if this is a normal distribution? Okay, the answer is, try to okay, here, I will do this on this corner here. So you type in equal norm dot inv, opening bracket, you type in the area to the left of that Z half alpha. It is 95%. And then mean is 0, standard deviation is 1. Okay, that is the critical value for 90%. That 1.645, 1.645. So this is how you 0 and 1, then you get 1.645. That is how you found the critical value. Okay, if you can do 90%, you can do any percentage. So that is when it is normal. And when it is a student distribution, T distribution, you need sample size to find the critical value. For T distribution, we still use those three common percentage, 90%, 95%, 99%, okay? But just for illustration, this time I will give you any percentage because the test will not give you 90%, 95, 99, give you maybe 92%, okay? And if I give you sample size, maybe 28, and I ask you what is the critical value, and suppose this is two-tailed test. So you have 92% here. And what is this T half alpha? That is the question. Okay. And to do that, if it is two-tailed, the Excel need to know what is the area for two-tail. Area for two-tail. So if you know the central area is 92%, the area for two-tail is 8%. And that is the probability. And then Excel also need to know degree of freedom. Usually it is sample size -1. Okay, So once you understand those two items, you can go to Excel, type in t.inv.2t. Opening bracket, probability, type in 8%, degree of freedom, 27. Okay. And you get 1.819. So that is how you found a critical value for T and for normal distribution. And also our textbook throughout the unit mentioned about type 1 error, type 2 error. That is also important. Remember, our hypothesis test is targeting population H0. Okay. So the result of H0 could be true, could be false. Okay. And when you make decision, your decision, what can you do with the H0? You can reject H0. This is your decision. And you can fail to reject. You do not reject, fail to reject H0. So any questions about your decision? You only have two choices, reject or fail to reject. When H0 is true, you reject H0, you are making mistake. That mistake is type 1 error. Okay, that is type 1 error. And when H0 is false, you reject H0, you are correct. Now let's look at this combination. When H0 is true, you fail to reject H0, you are correct. But here, when H0 is false, you fail to reject H0, you are making mistake. That mistake we call type 2 error. Okay, so that is type 1 error, type 2 error. Okay. And also, any questions? So when you are doing hypothesis test, every test has condition. Most often, those are commonly met conditions or requirements. We ask data is normal distributed, and data are random. Data are independent of each other. Those are the regular requirements for most tests, and specific tests may sometimes demand a specific requirement. Okay, so that is a general concept review of hypothesis test. Okay, and go back, recall from last class, we did hypothesis test for population mean. Okay, so that is a hypothesis test for one population. For one population, we usually need to know if the population mean is equal to a claimed number or not. Okay, so again, you have two situations, z-test and t-test. The test statistic for z-test is use sample mean minus population mean divided by population standard deviation sigma over square root of sample size. Of course, this is suppose population standard deviation sigma is null. Okay, this is z-test. And for the t-test, the test statistic use X bar minus mu over sample standard deviation S over square root of sample size. Okay. Of course, there is a hypothesis test for population proportion, but we emphasized on one population mean. We emphasized on the mean. Okay. So that is one population. And last week, we also did two population. And again, we focus on comparing two population means. Okay. And when you're doing the two populations, there are different situations. There are different situations. Okay. Situation one is two independent populations. Two independent populations, okay? And also we assume population one, standard deviation, sigma 1, and population 2, standard deviation, sigma 2. We don't know. So if this is the situation, the test statistic T equal to use sample 1 mean minus sample 2 mean, and then minus population 1 mean minus population 2 mean, and then square root of sample 1 standard deviation over sample 1 size plus sample 2 standard deviation over sample 2 size. Okay. Because you are using T, you need to find the critical value. The degree of freedom is smaller of N1 minus 1, N2 minus 1. So that is a two independent sample test. Two independent sample test. And also, we don't know sigma 1, sigma 2. And also, they are not, and not assume they are equal. So, and also sigma 1 not equal to sigma 2. There is another condition. So then the second one is still two independent. And we don't know sigma 1, sigma 2, unknown. But we assume they are equal. If this is the situation, we use different test statistic. Okay, so we use on the top, it is the same, x1 bar minus x2 bar, mu1 minus mu2. On the bottom, we use pooled variance. SP square represent pooled variance. I will give you the formula for SP square in 1 second, okay? So SP square called pooled variance. It is calculated from sample 1 and sample 2 standard deviation. So this is the formula. Sample 1 size plus sample 2 size minus 2. Okay. And in this case, degree of freedom, N1 plus N2 minus 2. That is when we assume sample variance are the same. Okay. So those are two independent. And then we have dependent samples. Okay. Two dependent two dependent samples. And for dependent samples, we calculate the difference first. For example, I want to compare the height between a husband and a wife. So those are the height for husband and wife. This is first pair, and another pair, husband height. And still another one. Just for example, okay? So you need to calculate the difference. We call that difference is D difference. So use 180 minus 150, 175 minus 152. 183 minus 164. So calculate the difference first, okay? Once you calculate the difference, etc., etc., you calculate the average of this difference. And those average, we use D bar, the average of this difference, okay? So the test statistic equal to D bar, the average of the sample, okay, minus population difference, mu D, and then divided by SD. SD represent standard deviation of this sample, this difference, standard deviation, okay, SD, our square root of n. Okay, so those are the two dependent samples, right? Those are the concept, the formulas behind. Remember last class we did hands-on, we did go through lots of examples. Okay, and this is review what behind what we did last class. Okay, remember you see this is last class, I did annotation here. Okay, this is what behind those output from SPSS. So far, we actually used the critical value method. We calculated the critical value here. And another popular way to conduct the hypothesis is to use the p-value. P-value is a universal. Any test can use the p-value method. And this rule, this protocol is universal. When p-value is smaller than alpha, we always reject H0. So when you use p-value, okay, we always based on this principle. P-value smaller than alpha, reject H0. Alpha usually 0.05. Okay. So any questions? So that is some review, and I hope those review will help you to understand some midterm questions. Okay, so the midterm will be closely related to what we did in class, okay? All right, so this is just a review, okay? Any questions? Okay, now as a review from SPSS, I will also do a question from lesson 25, so that you know what you are expected for your assignment. Assignment questions all coming from the textbook exercise questions, okay? So I have a question. We will have to calculate hypothesis test by hand on the midterm or through SPSS. Good question. You can calculate the test statistic by hand, or you can calculate by SPSS, unless the question specify you use the formula like this one here. So read requirements. Normally, I would not restrict which method you have to use normally, but some questions I do ask you use formula or by hand, something like the critical values. Okay. Any other questions? All right. So now I'm going to go to lesson 25 as a review from last class, one-way analysis of variance. I'm going to do review by complete an exercise from textbook. Okay, so that is lesson 25. And last time we did this example. So today, right now, I'm going to do a question from the textbook here. Exercise. I will do this one. Exercise for lesson 25. Okay, and your 10% assignment is all from exercise from different units. So by doing this exercise 25, I will show you the procedure, the expectation for assignment. At the same time, we review for one-way analysis of variance. Okay. So I'm going to copy this to my OneNote so that I can make annotation. Please stop me if you have any questions, okay? All right, try to also see your chart. Okay. A researcher is interested in whether the brownettes, and the redheads differ with respect to their extrovert tendencies. The researcher randomly selects 18 men from his college. And those 18 men include 6 blondes, 6 brunettes, and 6 redheads. And he then administers a measure of social extroversion to each individual. So let's open that data, and then I will explain what you are expected to do. There are 3 questions. 3 questions. Okay. So let's open the data. Remember, the data set is available on Sakai. So here I have on my computer. Data set. Yeah, this is the data set. So this, you need to open lesson 25, exercise file 1, exercise file 1, because there is other questions, exercise file 2. Okay, so double click to open it. All right, so this is our data. For the hair color, you have 3 groups, okay, and those are the measurement for their extrovert social behavior. Okay, so our objective here to compare the mean for each group. Remember, we have 3 groups based on the hair color. We want to see if those 3 groups means are the same, or at least one mean is different from others. So we are going to conduct, just try to copy and paste this. So this is our data. Maybe I'll paste it here. So question 1, conduct one-way analysis to investigate the relationship between hair color and social extroversion. Okay. On the output, identify F ratio, sums of squares, mean for red hairs, p-value for the hair color effect. This might be your midterm question. I will probably just change the data and I will ask you what is F ratio, what is sums of squares, what is p-value, what is test statistic. Okay, so I will ask those questions. And I will also ask you, what is null hypothesis? What is alternative hypothesis? Okay, so let's let's first of all, write down what is null hypothesis? Null hypothesis is H0. Can someone try to give us a statement for null hypothesis? What do I write for H0? Anyone? You are comparing 3 population means, and the hypothesis test is targeting population. So H0 said all 3 population means are equal. Mu1 equal to mu2 equal to mu3. Thank you, Rhoda. Great. And alternative means opposite of H0. Opposite of H0. So you can say at least, oops, right. At least one mean is different from others. Okay, so that is your H0 and H1. Okay. And finally, your conclusion about H0, you either reject H0 or fail to reject H0. In other plain English, H0, H1, one of them is correct. You have to pick. Pick one. Do you pick H0 or do you pick H1? Okay. And how do you know which one to pick? You use critical value method or p-value method by conducting one-way analysis of variance. Okay. All right. So let's do the analysis. So where is my SPSS? Okay, it's here. So to do the analysis, you go to analyze. So go to analyze. General linear model. And then quick univariate. Now the dependent variable is extra. That is dependent variable. And hair color is a fixed factor. Okay. After that, quick options. In options, usually you want to get descriptive statistic, estimate of effect size, homogeneity tests. Usually you select those 3 items. And then you click continue. Okay, so that is in the options. And then under the EM means, this is estimated marginal means, display means for this one, you can ignore this one. Okay. Continue. I will just click continue button. The question also asks us to include the appropriate post hoc. Okay. So you click post hoc, and then test for move the hair color for post hoc. So there are two situations. One, equal variance assumed. If equal variance assumed, we usually will select a 2K test to see which two groups. By the way, the post hoc test is applicable only when you found a difference among the means. So you want further to find out which two means are different, or all the three means are different. You use post hoc. Okay. And if equal variance not assumed, people usually select Donut C. Okay, so then click continue, and then click OK button. So this is your output. This is your output. You have a basic statistic. What is the mean for each? I'll try to. So the mean for each group, for example, the mean for blonde 5.13, the mean for brunette 3.67, etc. Those are descriptive statistics. And our question is, are those three means are the same or different? Okay. If you ask, don't we already have three means? You see, they are different. Okay, the number here represent only sample data. Based on this three sample means, we want to draw conclusion about population. We want to see if the population means are the same or different. Because this is some students confused. Don't we already have these three means? See, they are different. Yes, they are different. But how do we know they are different at the population level? We don't know. That is what we are doing now. Okay. And the Leibniz test of equality of variance. Usually, Leibniz test is to say if the variance are the same or not the same. Okay, based on the mean, you see the sig. By the way, SIG sig in SPSS is the p-value. Okay, so p-value for Leibniz test is 0.25, and this number greater than alpha. So equal variance assumed. Okay, so population variance assumed. Okay. And then you have a test between subjects. Okay. Remember, we have the overall, the model represent overall significance. The F test statistic, because this is important, I try to copy to make annotation about this table. Okay. Right. Okay, the overall model is here. See the model? You just look at the p-value. P-value. And this p-value 0.056. 0.056. This p-value alpha. This is p-value. P-value greater than alpha. Remember, alpha usually 0.05. And this number greater than alpha. That means the model is not significant. Okay. The model is not significant. And you can see from the F-test this is F-test statistic. And how do you get this number? You can actually, once you get this statistic, you compare with the F critical value. But since the p-value is simple, you directly get p-value. So this one, but you need to report this value because the question asks you F ratio for the group effect. So the answer is 3.511. So for your assignment will, all assignment questions coming from exercise in the textbook. So please clearly label your questions and label your answer. Okay. So we answered question A. And question B, sums of squares for the hair color effect. Sums of squares for the hair color effect. See, sums of squares is here. For hair color, see, hair color. So the answer is 24.1111. So next question, mean for red hats. So see the mean means mean square for red hats. Means I don't have it is here. It is just for red hats. Or the mean for red hats is here. Remember we get statistics. Descriptive statistics, the mean for red hats, 2.33 here. Where is my mouse? 2.33, okay. And then p-value for the hair color effect. P-value for hair color effect. So this is hair color effect, p-value. P-value is here. 0.056 for hair color effect, 0.056. Okay. All right, so we answered question A. And question 2, what is the effect size for relationship between hair color and extroversion? Effect size. The effect size measures how much variance for the dependent variable are due to the groups. Okay, and you go to the output from SPSS. So the effect size, you need to know in ANOVA test, effect size is measured by partial eta square, partial equals square. Okay, so you're looking for the effect size for the group. So it should use this one here, 0.319 under the hair color. Okay, so I'll go back here. This one here is the effect size for the hair color group, 0.319. That is the same as 31%. Okay. So that is this question. And then Question 3, create a box plot. Question 3, create a box plot to display the means. Okay, so to create box plot, you go to graph, legacy dialog, and then box plots, not line chart. Should get the original data. Okay, go to graph, legacy dialog, and then box plot. Okay. And click simple, and then it is based on summaries for groups of cases. Click define. So variable, select extrovert is variable. Category is based on hair color. And then you click OK button. So this is the box plot showing the 5-number summary for each group. So for example, I'm going to copy this to make annotation. So 5 number. So for group, for blonde, you have a minimum. Q1 is here, Q2, Q3, Q1 represents 25th percentile, Q2 50 percentile, Q3 75 percentile, and this is maximum. Those are the 5-number summary to summarize our data. Okay. So that concludes the review part. Hope through this review, you get idea what you are expected for your assignment, 10%, it is this format. And hope you will get a sense what kind of questions will be on the test. So on the test, I may give you a data and I will ask you similar questions like that. Okay. So those questions, I can give you multiple choice questions, or I can give you fill in the blank. Okay. All right. So, any questions? Oh, there's a question here. Okay. All right. Shall we take a break? After break, we'll move on. Lesson 2-way analysis of variance. Lesson 26. Lesson 26. So let's say I'll check the come back at 2:10. Okay, 2:10 we'll do lesson 26. Okay, so I'm going to type in here break. Back at 2:10 for lesson 26. So I'm going to stop recording. When we come back, I will start recording again. Stop recording.